channel. If you are watching this video, please hit the subscribe button for more videos like this, where you will learn how to solve mathematical problems with ease. Still on change of subject formula, we will be looking at more examples on how we can make variables subject formula of given equations. And today we are going to look at two different scenarios whereby we have a square root and we also have an equation which involves fractions, and the denominators of the fractions are linear expressions. So we'll start with the first question, which says make A the subject formula in the square root of a plus y is equal to z. So whenever you have a square root in a given equation in which you want to make a particular variable the subject formula, the first step to take is to do away with the square root. And in this case, you see that the A in which you want to make the subject formula of this given equation is enclosed or is under this square root sign. And the opposite of square root sign, the opposite of square root is a square. I would definitely have to do away with this square root sign in order for the A in which you want to make the subject formula to be free. So we first of all take the square of both sides in order to do away with the square root. So take square of both sides. Taking square of both sides, we have square root of a plus y all squared is equal to z. The square is equal to z squared. The square, we cancel the square root sign, and we are left with a plus y is equal to z squared. Remember, we have to make our a the subject formula, and the variable preventing a from being standing alone on this other side of the equation is y, or plus y. So we take plus y to the other side of the equation so that a will stand alone on this side of the equation. And in taking plus y to the other side of the equation, the positive y will change to negative y because it crosses the other side to the right hand side of the equation. So we now have a is equal to z squared minus y, and we have successfully made our a the subject formula in this given equation. So we'll take the second question, which is make a the subject formula in x squared plus square root of x squared plus a squared, which is equal to 3a. Just like we did in the first instance, we'll take the square of both sides in order to do away with this square root sign. Square both sides. We have square root of x squared plus a squared all squared is equal to 3a all squared. The square, we do away with the square root sign. We are left with x squared plus a squared is equal to, here, this square outside the bracket is going to affect the 3. It will also affect the a. So 3 squared is 9, and we have our a squared. So that is x squared plus a squared is equal to 9a squared. We are going to collect like terms. We collect like terms. Collect like terms by taking a squared to the other side of the equation in order to meet 9a squared. So in doing so, we now have x squared is equal to plus a squared will move to the other side of the equation, and it will give us 9a squared minus a squared. The a term is repeated here. We have a 9a squared, we also have a squared. But but we are looking for A as our subject formula. So we'll make sure we factorize the right hand side of the equation where we have A. Now give us is x squared is equal to, the common term here is A squared. So in factorizing, you put the common term outside the bracket, which is A squared. Open the bracket, you write down the expression in which you want to factorize, which is 9A squared minus A squared. Close the bracket. Now, divide each term in the expression you want to factorize. Divide it by the common factor, which is A squared. That is 9A squared divided by A squared all over minus A squared divided by A squared. A squared will cancel A squared. A squared divided by A squared will give us 1. We are left with x squared is equal to A squared, open bracket, 9 minus 1, close bracket. We have x squared is equal to A squared, bracket, 9 minus 1 will give us 8, close bracket. In order for us to now make our A squared to be alone, so that we can make A solid formula, we divide both sides by 8. Divide both sides by 8, so that 8 we cancel, we go with 8. And when 8 goes with 8, we are left with, when 8 goes with 8, we are left with A squared is equal to x squared all over 8. Or x squared all over 8 is equal to 8. So now, A squared is not the subject formula. We have to make A the subject formula. So we'll take the square root of both sides in order for A to be alone on that side of the equation, because the opposite of square is square root. So we'll take. So now we are going to solve the last question, which requires us to make x the subject formula in x over s minus 1 plus t over r plus 1 is equal to 1. In this scenario, you can see that we have a fraction, or we have fractions in this equation, and then the denominators to these fractions, they are linear expressions. We all know that linear expressions are expressions in which the highest power of the unknown is 1. The highest power of s here, s is the unknown here, the highest power of s here is 1. The highest power of r here, which is the unknown, is also 1. So they are all linear expressions. So before we can make our x the subject formula in this given equation, we'll first of all do away with our fraction. And doing away with our fraction, the first step is to get the LCM. Taking the LCM of the fraction x over s minus 1 plus t over r plus 1 is equal to 1. The LCM will simply multiply the two denominators. Therefore, our LCM is equal to s minus 1 times r plus 1. We now use our LCM to multiply each term of this equation. That is, we multiply our LCM by s over s minus 1. We multiply our LCM by t over r plus 1, and also multiply our LCM by 1. So this will give us s minus 1 times r plus 1 multiplied by x over s minus 1 plus s minus 1 times r plus 1 multiplied by t over r plus 1, which is equal to our 1 here, our 1 multiplied by the LCM, s minus 1 times r plus 1. Our s minus 1, we go with s minus 1. R plus 1 will also cancel r plus 1. And now we are left with x times r plus 1, x times r plus 1, plus t times s minus 1, t times s minus 1 is equal to 1 times s minus 1 times r plus 1 will still give us s minus 1 times r plus 1. So you see that we want to make our x the subject formula, and t plus t times s minus 1 is preventing our x from being alone on this side of the equation. So first of all, we'll move our plus t bracket x minus 1 to the other side of the equation, so that x bracket r plus 1 should be left alone on this side of the equation. So we have x, by so we have x bracket r plus 1 close bracket, which is equal to bracket s minus 1 open bracket r plus 1. Our plus t here, we move to that side, we change to negative. That will be minus t bracket s minus 1 close bracket. Our x is not yet alone on this side of the equation. X on this side of the equation is multiplied by r plus 1. So look for a way in which you can move r plus 1 away from x, so that x will stand alone on that side of the equation, and it will become the subject formula of this given equation. X is attached to r plus 1 by multiplication. Therefore, to do away with r plus 1, we need the opposite of multiplication, which is division, to separate x from r plus 1. So we are going to divide both sides by r plus 1, so that our x will be left alone on this side of the equation. So we are going to have x plus r plus 1, x bracket r plus 1 divided by r plus 1 divided by r plus 1. So r plus 1 will go with r plus 1, and we are left with x is equal to s minus 1 times r plus 1 minus t open bracket s minus 1 all divided by r plus 1. We have succeeded in making our x subject formula. Thank you for watching.